All right. Hello, everyone. This is Rod Stellmuller, and this is another Tech Talk Tuesday. Today, we're going to be talking about bringing next generation firewalls to the cloud to simplify centralized cloud egress and ingress security. And this is actually one of the most popular use cases once people start deploying the Aviatrix cloud network platform, because it really makes it simple to insert next generation firewalls and other security services and connect them directly to the Aviatrix transit, which is a difficult task when you're just using the basic networking constructs and capabilities in the cloud. So today, Jesse Ebel, one of our senior systems engineers out of Southern California, is going to walk through how he's done this with many customers. And we have Shahzad Ali, one of our principal solution architects, who's going to be online to field questions. So please use the Q&A panel at the bottom of your screen if you have questions during the presentation. And we'll go ahead and answer those questions directly to you during the presentation, and then we'll highlight some of those questions at the end if we have time for Q&A. So with that, I'll turn it over to Jesse.
Great. Thanks, Rod. So quick agenda for today. First things first, introductions. Of course, my name is Jesse Ebel. I'm bringing to the table over 15 years of network and security experience. I've been with Aviatrix for about a year now. Previously, I was at Palo Alto Networks for about 10 years in technical support and the systems engineering organization. The last few years, I've been focusing on global accounts and helping them deploy multi-cloud security. So I can help answer some questions around why next generation firewalls in the cloud and some insertion challenges there in the different CSPs. And then we'll go into Aviatrix FireNet, so the solution and the integrations there with our partners like Palo Alto Networks, Checkpoint, and Fortinet. And then dig into ingress and egress design patterns. So a little background on Aviatrix. We've been in the market here for over 6 years doing software-defined networking in the public cloud. And we've got customers across all industries and verticals. So I think this is really a testament showing the common need for enterprise class networking and security in the public cloud. So the platform for Aviatrix, number one, we have our Aviatrix controller. This is software that you own and run and launch in your infrastructure as a service, and it functions as the control plane or management plane. And it will launch our Aviatrix gateways and also control and manage those basic cloud security constructs. And then it can launch and manage Fortinets, checkpoints, and Palo Altos as well within our firewall network or FireNet. All of this can be hooked up into our Aviatrix Copilot platform. And this provides our multi-cloud operational visibility, flow analytics and visibility on transit flows, as well as dynamic topology mapping, a great operational tool showing you what you have deployed out there, how it's connected, and what the best path is for that. So just to hit on a couple key value propositions here with Aviatrix. So what it's doing is providing that advanced networking foundation for multi-cloud enterprises. What we can then build off of that are some fundamental use cases like, peering up with on-prem using BGP and supporting overlapping subnets and IP ranges. And then we can apply advanced security. So doing segmentation in the cloud using security domains and providing high performance encryption. And we'll dig into FireNet service insertion during this call. And then all of this can be rolled up into advanced automation, infrastructure as code, right? So we are Aviatrix controller as a Terraform provider, and it can automate that inline security deployment. So why do you need a next generation firewall in the cloud? So it's really, I've heard somebody say this, there is no cloud, it's just somebody else's hardware, right? So it is still your apps, data, and users in somebody else's data center. And if you're looking at the risk profile, it's really the same or greater than those traditional or old school data centers. So if you're looking at the attacker, they still want to get access to that information. Your data, unless you've really modernized your applications and rewritten all your databases and have all of your IAM policies and landing zones sorted out, there's risk that's built in there. So there's a myth that was going around that stateful firewalls were enough for cloud security, but as you know, stateful firewalls aren't enough, right? They're only ports and protocols. So what's needed is a common security posture across your enterprise, from on-prem, remote sites, your cloud footprint, and covering your remote users. So this is like a context-driven policy based off of applications, user data, and using this system for threat prevention sharing. And then that common management for those next generation firewalls would be something like Panorama or some other central management platform. And the last piece here is really it enables advanced detection and response. For example, like XDR space, where it's correlating multiple sensors or points in the network between, say, network flows, endpoints, events, API security events, things like that, and correlating that for when you need to have network as a component of that for that inline deep packet inspection, because that's going to create the opportunity for visibility into command and control, exfiltration of sessions, and the opportunity to take action on that. And that feeds into the wider XDR strategy. So it's got the rich logs for machine learning and AI and that kind of threat prevention. And then if you're looking at the technical challenges of doing it yourself with community supported scripts and kind of suggested architectures, when you're looking at AWS, generally you're going to be deploying a AWS transit gateway and doing VPC attachments to that and deploying a, say, security VPC. The challenge here is that this is a manual deployment. So what you're doing is creating multiple route tables and then manually creating static routes for each one of these. So if you want to do segmentation, you're manually adding these routes. And then from on-prem, those routes don't propagate into the cloud. So you have other challenges there. And then when you want to do service insertion, that's where you have to use some kind of overlay where IPsec is generally used, and then they have to run BGP on top of that so that you can use ECMP to load balance across that horizontal pool of firewalls. The challenge here is that IPsec throttles the performance there, but you also need to keep that session sticky or on that same firewall for the full session. So that's where SourceNet comes in. And generally, InfoSec and other teams don't like SourceNet because then you can't see that true source IP address. Looking at Azure, so of course, there's community supported scripts. It's another kind of manual deployment. It's a little bit different with the ILB. You can communicate between VNets with no SourceNet, but then say if you're going on-prem or between regions, that's where you would end up seeing SourceNet. Also, there's some manual UDR programming here, which can be a challenge, especially when you're troubleshooting. And the visibility and security compromises. So no encrypted transits, no visibility into the spoke or transit flows at times, and inconsistent architectures. So each one of these, the next generation firewall feature set is beneficial. However, what they're doing is suggesting an architecture, a cloud architecture to build off of, which each cloud has a different architecture. So this is where challenges and operational aspects come into play. So Aviatrix FireNet or firewall network is where we can provide that multi-cloud service chaining and insertion. So here, just to kind of give you a quick overview of this diagram, we've got our control plane where our Aviatrix controller is kind of the brains of the operation, providing that software-defined routing and networking. And then we can then deploy using our Terraform provider inline security. So we have our distributed data plane down here with our transit VPCs. And each transit VPC has a spoke VPC connected to it. So we have our active mesh, active high availability, multi-AZ high availability. And then we also have the concept of security domains. So we would have this prod VPC security domain in green and the dev VPC security domain in blue. So then you can create what's called connection policies in the Aviatrix controller to define what's allowed between, say, prod VPC and dev VPC. And you can easily create, say, like a shared services VPC and create policy-driven segmentation and allow policies that steer the traffic dynamically and do the traffic engineering for that service insertion. So it covers all of your flows, essentially, east, west, north, south, ingress, egress. We have single and dual FireNet deployments. So this diagram is showing a dual FireNet in AWS, as well as a dual FireNet in Azure. And one FireNet's used for the east-west flows, and the other FireNet is used for egress. So there's no IPsec required here. So there's no compromises in terms of performance, no BGP required, and no source net. So our Aviatrix FireNet gateways are keeping those sessions sticky or symmetric and providing that scalability and resiliency. So the Aviatrix controller is providing that intelligence traffic steering, and you can create that connection policies using security domains. And these are global segments, meaning, or global security domains, meaning this segmentation extends to your other regions and other clouds consistently. So it creates that common abstraction layer for service insertion. And then the automation aspects of this, right? So the Aviatrix controller is deploying the next generation firewall and all the surrounding infrastructure, doing the traffic engineering and network correctness that it takes for that kind of service insertion. Also, advanced monitoring and visibility, which is really important. So this is a benefit. So once you go into Aviatrix Transit, you have the data plane back. So you can do packet capture, ping, trace route. Role-based access control is built into the controller, so you can provide access to the cloud resources to the right teams. And our Aviatrix Transit gateways provide that traffic rebalancing. So if you lose a firewall or an Aviatrix gateway, the resiliency is built in a multi-AZ scaled out fashion. So going into a little bit of the specific vendor integrations. So our first one would be Palo Alto Networks here. So it's a zero-touch VM series deployment with a bootstrapping integration. So it can come up with a initial configuration. And then once it's up, our Aviatrix controller can monitor that VM series pool for health and resiliency. And the FireNet gateways are an active mesh or active-active multi-AZ high availability. And that's providing that load balancing and that session stickiness between the VM series pools. And these can be scaled out to 10 VM series per AZ, so a total of 20. Our controller integrates with Panorama as well as PanOS to do the route programming. And then their wider architecture is really coming into play here with segmentation, with security domains, and the software-defined routing that all goes along with that. So no source net, IPsec required. Also, we have an integration with Checkpoint. So again, zero-touch cloud deployment with bootstrapping integration. The Aviatrix controller monitors the CloudGuard health pool for resiliency and does the same load balancing session stickiness without having to have BGP or IPsec. Integration with Smart Manager, so you can continue to control those CloudGuard instances with that common security policy that you would have on-prem, and you can manage this from your on-prem or cloud instance. And again, the wider architecture is really the extended value here of segmentation and architecture that's repeatable. One interesting thing around Checkpoint is their geo cluster active-active mode. They can put a CloudGuard instance in each AZ, and both of them are active. And that actually works really well with our active-active mesh. So we can provide some architectures there that are interesting. In Fortinet, you'll see the exact same trend here, right? So zero-touch FortiGate deployment monitors the health for pool resiliency, does the session stickiness. common security manager, so Forti manager. And then right now we're providing that segmentation and route propagation for private IP address space for the firewalls today, just in AWS. So kind of going into the demo here of the interface. So I brought up a Aviatrix controller and went into the firewall network, and we can launch a new instance. So I've got a single firewall A here in one availability set or availability zone. And what I want to do is launch a second firewall. So I have that resiliency. So I can show you this going through the interface manually here. So I'm selecting the management interface subnet and then the egress interface subnet. And then I'm going to create a username and password. I could click advanced here. This is going to give the option to do bootstrapping. And then we'll click launch. And if you've ever launched a cloud firewall, you'll know it takes about 5-10 minutes. So I went ahead and sped this up. But this can all be programmatically done and scaled out. So leveraging our API or Terraform scripts, you can essentially just change an integer and scale out your firewall network. So I've seen customers do this around time of day when they know they need to scale out that firewall so they can do it ahead of time, just because it does take some time to scale out the firewalls. So now you can see we've got our second firewall deployed. So it's automating all of those steps that are required around that firewall, right? Which subnets, we can see now we have 2 inspections enabled, but egress wasn't enabled. So here, if you wanted to enable egress, you can click enable. And then we have our vendor integration. So here's where that route programming comes into play. So you can create a unique user here for that route update. And we have other integrations, right, for Fortinet, Checkpoint. And then if you're using Panorama, we have the integration here too, you can configure. So there's really 2 main architectures you can look at. So there's single transit firewall network. So this would be a single transit VPC in a certain region. And then this would be covering both the egress and ingress flows. So you would have a external load balancer here and leverage SourceNet, but this would cover all the VPC to VPC communication, the on-prem flows, as well as ingress and egress. So you get the simplified policy management. So you're only managing one pool of firewalls instead of many. So this can be a benefit, but if you do want to segment that out, say you have an ingress VPC, you can also have a dual transit FireNet. So this, the dedicated firewall network would be doing VPC to VPC and on-prem, as well as egress traffic. And then you can have a second FireNet here for ingress security. So this is where the external load balancer would go. And then again, we would require SourceNet just for this to stay symmetric here. So you don't have to use those native CSP ILBs or ELBs. You can leverage F5 and some of their cool technology with iRules and Big IP. So there's some popular use cases. Our customers are doing load balancing or SSL or TLS offload. So it's really easy to deploy. So number one, you would deploy our Aviatrix Transit FireNet gateways. Then you would deploy the Big IP, F5 Big IP instances and attach those to the transit gateway. And last piece would be choose the traffic you want to be sent to the Big IP using the spoken inspection policies. So all of this you can then Terraform, right? So I think this is where we're seeing a lot of organizations when they're going multi-cloud. Terraform is the automation of choice or code of choice, right? So this is going to provide you a quick starting point when you leverage some of our Terraform modules. So if you go to registry.terraform.io, we have our Terraform Aviatrix modules. So you can combine these. So we have our transit FireNet for AWS, Azure. We also have transit for GCP as well. And you can combine these different modules to build out your global multi-cloud network. So it supports Palo Alto Networks, Checkpoint, Fortinet. So kind of looking at an example here. So here building out a transit FireNet in Azure using CloudGuard integration. So the controller would do all of the deployment, including the FireNet deployment and the CloudGuard instances, and all the required, VPCs, subnets, IP addresses, EIPs that are required. So looking at the code real quick. So looking at this Checkpoint Azure deployment. So if we dig into the code, you can see the main TF, you have to define username, password, controller IP, but it references a bunch of different variables. So you would specify the CIDRs that you want, spoke names, and then go into the variables.terraform file and then edit the variables that you need there as well. You can load this into Terraform Cloud, for instance, like this, to run it. So we've ran this previously, but just destroyed it. So we can go up and queue a new plan for the demo infrastructure. And this is going to go through the Terraform plan and apply. And you can see it's going to go ahead and add 12 new resources, change 0 and destroy 0. And when you're good, you can confirm and apply, tell everybody, yes, we're good to go. Now it's running the Terraform apply. We can go ahead and speed this up, but it's going to go ahead and create all of those resources contained in that Terraform plan we just walked through there. So once it's done, you'll get the log here, hopefully no error messages, but you'll see what was created. And this created the infrastructure. So you can create a multi-cloud transit infrastructure with firewalls with under an hour. If you're talking about multi-cloud, you can under 2 hours, you can end up doing all 3 clouds. So it's built the transit gateways along with the spoke gateways and the attachments to those. And going into the transit FireNet, it's created a transit FireNet with 2 firewalls, inspection yes, and egress yes. And we can see both of those firewalls in the upstate there. So the manage FireNet policy, this is great. What you would need to do is just include the spoke inspection policies for those 2 spokes. And then you can deploy additional firewall instances or see the existing ones running here. So with that, I'll go ahead and hand it back to Rod. Thank you.
All right, great, Jesse. Thank you very much. That was a great presentation. I just want to highlight a couple of things while we maybe jump into some Q&A. One thing is, if you saw anything that's interesting here and you'd like to connect with us, maybe get a demo for your team, send us an email at info@aviatrix.com. That's probably the quickest way to get to the right people. Also, if you want to look at any of the documentation behind all of this, we have that up on our website at docs.aviatrix.com. And you can always go to our chat on the website, and that is usually manned by our solution architects. So we have technical guys there that can answer technical questions. And then finally, if you are interested in certifications, we have the ACE or Aviatrix Certified Engineer certification that starts at the associate level, which is a self-paced class. It takes about a day, about 5 hours to go through, and you can actually get a certification if you pass the tests and so forth. So I encourage you to take a look at that. And we have several levels of that going into professional and design as well. We have a poll popped up right now. I really appreciate it if you guys could go through and answer the poll questions, just a few of them, and it's really helpful for us to get some feedback on that. So let's jump to maybe a couple of questions that came across on the Q&A. Shahzad, you want to throw out a few?
Yeah, there are some good questions out there. So I see one question was about the licensing and how flexible we are. So yeah, so in terms of licensing, you can deploy these the firewall images, because I believe the question was about the firewall licensing, not our licensing. So you can deploy them in the metered fashion, where you can do pay as you go, and then BYOL. So you can talk to your vendor, the Checkpoint, Palo Alto. They can give you the license that you can use. Another option is that I have seen customers do some uh, private offer types, right, where you have already deployed the firewall. So we can consume those firewalls and attach them to our platform as well. So you don't have to deploy everything, all the firewall from our controller. If you have already deployed the firewall, we can bring it and make it part of this architecture. So that was one question. And another question was around, okay, I have the firewall network, or I want to deploy a firewall network in one cloud. In the other cloud, I don't have much presence. So can I attach the spokes to my primary cloud and then get the inspection or deep packet inspection done that way? So the answer is absolutely. The architecture is very flexible. You can deploy this transit in, for example, AWS, if it is your main cloud. And then in Azure, you can deploy spoke gateways, and you can create the policies, because remember Jesse showed you these policies that cut across multiple clouds. And when you create the policy, your traffic will be inspected by this main firewall or the firewall network in your primary cloud. Now here you have to be very careful, because when your traffic is crossing the cloud, you will be paying extra charges for this cross cloud connectivity. So from the cost optimization point of view, the recommendation is to deploy these FireNets in their respective cloud so that your traffic can stay within the cloud. And that is also a best practice from security perspective, that you want to inspect the traffic close to your workload. So that was, yeah. And
Hey,
the last one, I'm sorry, Rod?
I was going to say, I just saw one come across talking about our Terraform provider. You want to check that one out? It looks like a good question.
Yeah. Oh, yeah. So for the Terraform, so this question is about, is there any aviatics specific information using Terraform? Oh, yeah, we have absolutely tons of information available on our website on Terraform. And there are some members from our customer community who have created these Terraform scripts to solve their problems or to automate their network. So there's a lot of information out there. If you are looking for a specific Terraform code or want to achieve something very specific, you should talk to us, and most likely we will provide you the code or will help you in terms of, okay, this is how you do it if
Yeah.
you're stuck or something.
And I'd just add that it is a multi-cloud Terraform provider. So when you create a module, that module is going to be able to work in any cloud and deploy a repeatable design, because it's actually talking through the Aviatrix controller and using a single set of APIs to do the same things in different clouds, leveraging that abstraction layer that Jesse talked about early in the presentation.
Yep. Yep. And I will just mention this last one here, because this is again about cost optimization. So this customer is asking about, I just need to do URL filtering for the traffic that is leaving from my cloud towards the internet, the egress traffic. Do I still need these deep inspection type solution or these firewalls? So the answer is no, not really. If your use case is just to inspect the traffic based on the FQDN or URL, you should consider Aviatrix egress FQDN solution, because that is more cost optimized and will give you more flexibility in the sense that you can deploy this solution in a distributed fashion, where these egress FQDNs are deployed into their respective VPCs or VNets, or you can use a centralized model where you can bring all the egress traffic to a centralized VPC or VNet and send the traffic towards the internet. So I
Okay.
think that is all from my side.
Okay. Can you jump to the next slide there, Jesse? Thanks. So I just wanted to highlight a couple of upcoming Tech Talks and other webinars. On October 29th, check out, we have one, you can go to our website and look for the customer flight plans. This is actually where we're hosting our customers who are talking about their deployment. In this case, it's National Instruments, or they call themselves NI now, who are going to be talking about how multi-cloud optionality became critical to their business because of a merger and acquisition, and being able to bring those two cloud environments together with our multi-cloud networking was a great thing for them. On November 3rd, we're going to be talking about building a multi-cloud network architecture across AWS and Azure, and some of the details about how that works and how to bring those two things together. On November 10th, we're going to talk about serverless with Aviatrix. So as you all know, there are technologies like Lambda in AWS and Cloud Functions in Azure and others in Google that are really exciting in terms of serverless app deployment. But the challenging part about that is that the networking in the cloud isn't really there to the level that a lot of people need. And so with Aviatrix, you can connect these serverless functions directly to the Aviatrix transit network, and then be able to take advantage of all the advanced security, advanced networking, advanced visibility, and so forth that we offer, but do that to support your serverless connections. And then on November 12th, we're doing a webinar with Worldwide Technologies, WWT, and talking about what some of their customers are seeing and doing with the Aviatrix platform. So with that, I want to thank Jesse and Shahzad and all of you for attending the Tech Talk, and we'll see you on an upcoming Tech Talk Tuesday.